Hello viewers, I'm Kausalya. Today we are going to solve some more problems related with transformer losses. So problem 1, in a transformer, the core loss is found to be 52 watts at 40 Hz and 90 watts at 60 Hz measured at same peak flux density. So here you see the flux density remains the same and the value of loss is found to be 52 watts at 40 Hz and 90 watts at 60 Hz. Now we are going to find the value of this eddy current loss and hysteresis loss at 50 Hertz. Right. So what is the formula for eddy current loss and hysteresis loss? You see this is the formula for eddy current loss and this is for the hysteresis loss. Right. So here the thing is, you see the flux density, same flux density. What does this mean? The flux density remains constant. Right. So here in both the cases, the flux density is same, or in other words, we can say the flux density remains constant. So, we are simplifying this formula as, that is, eddy current loss is directly proportional to frequency square, and again the hysteresis loss is directly proportional to the frequency. Right. So, we are rewriting the formula as total core loss is nothing but it is a summation of hysteresis loss and eddy current loss. So here you see this is your hysteresis loss and this is your eddy current loss. Right. So hysteresis loss is directly proportional to F. So here we can write it as the proportionality constant is A. So we can write it as PH is equal to AF and similarly PE is equal to BF square. Right. So here just substitute the values AF plus BF square. So here F is constant, F is common, it is present in both the places. So take F outside and finally we have A plus BF. And again when you move this F to the left hand side, it becomes WI by F is equal to A plus BF. Right. So now we have two different values, right? You see it is 52 watts at 40 Hertz and 90 watt at 60 Hertz. This is the power and this is the frequency, and we have framed an equation in terms of that is power and frequency. So just substitute the values over here. So 52 by 40 is equal to A plus the value of frequency is 40, so 40B. Similarly, for the next case, it is 90 by 60, which is equal to A plus 60B. Right. So here we have two equations. Once you solve these two equations, right, we can easily find the value of B as well as we can find the value of A. Right. So once you know the value of A and B, we can easily calculate the value of hysteresis and eddy current losses at 50 Hertz. Right. So at 50 Hertz, the losses are, you see hysteresis loss is equal to A into F. We know the value of A and the frequency is 50 Hertz. So just substitute the values and finally we end up with the answer as 45 watts and 25 watts. Right. Now we proceed with our next problem. So in a test for the determination of the losses of a 440 volt 50 Hertz transformer, the total iron losses were found to be 2500 watt at normal voltage and frequency. So here again, you see this is a 440 volt 50 Hertz transformer, right? So the test is conducted and the iron losses is found to be 2500 watts at normal voltage and frequency. So here the normal voltage is 440 volt and the frequency is 50 Hertz, right? Now, when the applied voltage and frequency were 220 volt and 25 Hertz, right? We are changing the voltage as well as frequency. Now, the iron loss is calculated to be 850 watt. Find the eddy current loss at normal voltage and frequency. So, here two different scenario is given. Once you see the 2500 watt is the iron loss when the supply voltage is 440 volt and 50 Hertz. Again 850 watt is the loss when the supply voltage is 220 volt and the frequency is 25 Hertz. Now we are expected to find the eddy current loss at normal voltage and frequency. Right. So when you look carefully, you see here it is 440 and here it is 50. And in the second case, it is just reduced to half. Here it is 220 and again 50 by 2, it is 25 Hertz, right? So, flux density remains the same in both the conditions because voltage and frequency are halved. They are exactly halved, right? First case it is 440 and the second case it is 220. And first case the frequency is 50 and second case it is 25. Right. So here again the flux density is constant. So as we all know, eddy current loss is directly proportional to F square and hysteresis loss is proportional to F. Again we are introducing proportionality constants. Here it is A and for eddy current loss it is B. So total iron loss is nothing but it is the summation of hysteresis loss and eddy current loss. Again we are doing the same thing. We are substituting the values and F is commonly taken outside and finally we end up with this equation. So again you see when the value of frequency is 50, the loss is 2500 and frequency is 25, the loss is 850. Again simply substituting these values in this base equation and we are calculating the value of A and B. Right. So this is our equation 1 and this is our equation 2. Once you simplify, we find the values of A and B. So this is the value of B which is 0.64 and we have calculated the value of B, right? So here we need to find the eddy current loss. So eddy current loss is represented by B into F square, right? So the value of B is 0.64 and the normal frequency is, it is 50 Hertz. So 0.64 into 50, this gives the value of eddy current loss which is 1600 watt, right? So we are finding hysteresis loss too. So hysteresis loss, that is we all know, right? The core loss or iron loss is nothing but it is the summation of eddy current loss plus hysteresis loss. So I need hysteresis. So hysteresis loss is nothing but iron loss minus eddy current loss. So the iron loss at 50 Hz frequency is 2500 and the eddy current loss is 1600. So finally we end up with the answer as 900 watts. Right. That's it. We proceed with our next problem. So here the problem is when a transformer is connected to a 1000 volt 50 Hz supply. The core loss is 1000 watt of which 650 is hysteresis and 350 is eddy current loss. If the applied voltage is raised to 2000 volt and the frequency to 100 Hz, find the new core losses. So here you see 1000 volt and 50 Hz. 1000 volt is a supply voltage and 50 Hz is the frequency. Here the core loss is 1000 watt. Okay, the total core loss is 1000 watt and again they have splitted that into hysteresis loss and eddy current loss. Right. So if the applied voltage is raised to 2000 volt. Right. Here it is 1000 volt. I am increasing the supply voltage to 2000 volt and the frequency to 100. Now we have to find the core losses. Again core loss is nothing but hysteresis loss and eddy current loss. So here you see hysteresis loss, again it is given by this formula, right? It is directly proportional to B max to the power 1.6 into F. Again a proportionality constant P is introduced. And in eddy current loss, this is directly proportional to B max square F square. And here Q is the proportionality constant, right? Q, B max square, F square. So here we again reframe the EMF equation of the transformer. So from the EMF equation of the transformer, you see the value of B can be calculated. B can be written as, I am moving this F to the left hand side. So this occupies the denominator part, right? So B max can be written as, this is directly proportional to E by F, right? Am I making sense here? I am simplifying the equation. This equation I am rewriting in terms of B max. So here you see everything is fixed here. Right, apart from this frequency, you see number of turns, area, these are all set. So B max can be written as E by F. It is directly proportional to E and inversely proportional to F. Right. So again you see the equation for WH is given by P B max to the power 1.6 into F. So P into B max is written as E by F to the power 1.6 into F, which is equal to, again I am splitting the power, right? E to the power 1.6 and F to the power 1.6 into F. So again when you simplify, you see F to the power 1.6 and here F to the power 1. So when I move this to the upside, what happens? This is F to the power 1 and this is F to the power minus 1.6. So when you simplify, minus 1.6 plus 1 gives minus 0.6, right? Similarly, we are framing equation for this eddy current loss too. So this is nothing but Q B square F square, and this is the value of B. Again, when you simplify, we end up with Q E square, right? So now we are going to substitute the values. You see, when it is 1000 volt and frequency is 50 hertz, we are calculating the loss. So WH is given by this formula. Again here we are substituting the value of E and F, and the value of P is calculated as 0.10772, right? We are substituting the next value. So here the given thing is, so this is my eddy current loss. So eddy current loss is given by Q into E square. So just substitute the values and calculate the value of Q, right? So now we are going to substitute the values of P and Q in calculating the final value. So hysteresis loss is given by this equation. Here I know the value of P. The value of E and F are given in the problem. Just substitute it and here we got the answer as 1300 watt. And again here WE is given by QE square. So we know the value of Q and the value of E. So just substitute and here we get the eddy current loss as 1400 watt. So what is the total loss now? Total loss is, you have to sum these two values. So just add this and the final answer is 2700 watt. Right. So that's all in this video. I believe here the problems are purely based upon the formulas. Once you know the formulas, it is very easy to go with. So that's all. If you have any doubt, let me know in the comment section. Thank you.